Hello. This video is going to look at number systems. My aim is to explain what a number system is, why we use them, the number system that you're used to using, and introduce a new number system, which is binary, which you need for the computing course. So, first of all, we need to think about what numbers are and what we use them for. So, hopefully, as you're taking computing, you're fairly numerate. You're quite good with numbers. You should have a B in maths, hopefully. So you should be quite good. Numbers, well, that's easy. Things like this. These are numbers. They're used to represent values, maybe quantities. Maybe amounts. So we use them to represent. Now this word, represent, is key. We use them to represent numbers. So this here, change, this represents the number 8. It isn't the number 8, it merely represents it. I'll give you an example of what I mean. Maybe your family at home have 2 cars. Here's my car, looks just like this. It's got one red wheel and one green wheel, just like all cars do. But I've also, of course, got a much sportier car. There we go. Look at that. So there's a representation of 2 cars. Maybe you did that when you were a little bit younger. In primary school, you might have started off representing values or amounts by drawing a number of things. You might have used apples, for example. But then, hopefully, you've moved on from this, and we wouldn't draw the cars. We might use a combination of numbers and letters to represent what we're talking about. So here we have a number, 2 cars. I mean, I could represent it in another way. The Romans didn't have cars, but I could use a Roman numeral to represent 2 cars. So all 3, we've got 3 different ways of representing the same thing. I could represent a value by drawing the number of things. I could write it out using numbers. I could write it out using Roman numerals. Another example is you could write it in different languages. So if I want to write the number 1 in English, I can represent the number 1 by using that word. In German, I would write that. In French, in Italian, etc. All representations of the number 1 or the value 1. So I could use this, or this. They're all representing a number 1. I think I might have zoomed in a bit there. So we have this idea that we can represent numbers using these numbers. We had some examples at the beginning, like 8 and 196, representations of a number. They're not real numbers, they're not real quantities, they're just a way of writing them out or communicating them. Of course, one of the things we can do with numbers is to do sums. We can represent values, we can perform an operation, in this case an addition, and we can show what the answer is. So 2 add 3 is 5. So if we take 2 of something, add 3 of something else, we get 5 in total. So it could be, if one person has 2 sweets, another person has 3 sweets, in total there are 5 sweets. And we can do this with larger numbers. We can do different operations, such as subtraction. Hopefully I've got that right. 128 minus 15 is 113. so we can do different operations. But again, this is just a way of representing these calculations. They might represent a real thing, like I had 128 sweets and I ate 15, now I've got 113 left. It could be the number of people that were in a school and a certain number left, how many we got remaining. It could be many different things, but it's just a representation. Now if I take this top one, 128 minus 15 is 113, let's look at what this means. Why do we write it in this way? Why not write it in Roman numerals? We could do that. What this is, you have to remember back to primary school. The 1 represents hundreds, the 2 represents tens, and the 8 represents units. So this is how many ones there are, this is how many tens there are, and this is how many hundreds there are. So in other words, we could write this out as being, it's 1 times 100 plus 2 times 10 plus 8 times 1, which 1 times 100 is 100, 2 times 10 is 20, 8 times 1 is 8, so the total that we're representing here is the number 128, although of course I've used the same representation so it looks the same. But it's showing us that we have 100 of something, 20 of something and 8 of something, so in total that's 128. And this is how, hopefully, you've learnt your maths or your arithmetic or numeracy, by using these columns. So that we have the ones, the tens and the hundreds. This number system is called base 10. And this is a number system you've grown up with. If I write out column headings again, we had ones, we had tens, we had hundreds. If I go up again, it becomes thousands. I'm going to try my best to just draw some straight lines in here. There we go. And we can represent numbers using these columns, any number really. The other thing to remember, is that each column can have a digit in it, and the digits range from 0 all the way up to 9. So in the ones column I could put a 0, a 1, or a 2, or a 3, or a 4, or a 5, or a 6, or a 7, or 8, or a 9. But the biggest digit I can have in any column is 9, and the smallest is 0. So as an example, let me just get rid of that. We can have numbers such as 930. So 0 is, there are no units, you can't get lower than that. 3 tens, 9 hundreds. Now I can't have any more hundreds in this column. If I wanted to have one more hundred, that would have to become a 1, and that would have to become a 0. Which, if you think about it, is what you know and what you would do. 930 add 100 is 1030. So we have a system here where we've got columns that start at 1 and go up by, every time, go up by 10. Every time, multiply by 10. So the next column, you would multiply by 1000 by 10, would you get 10,000, then 100,000, then a million. And we have these columns. In each column, you can have one of the digits from 0, between 0 and 9. Now, the other thing to notice is these columns could be written slightly differently. I could write, instead of writing 1, I could write 1 is 10 to the power of 0. 10 is 10 to the power of 1. 100 is 10 to the power of 2. and 1000 is 10 to the power of 3. So this is basically the blue writing here and the red writing are basically saying the same thing. Anything to the power of 0 is 1. Anything to the power of 1 is itself, and then we go up by powers. The next one will be 10 to the 4, 10 to the 5, 10 to the 6, and so on. They're just going up by 1 each time, which is really saying the same thing as this, that they're being multiplied by 10 each time. So here we have base 10. This is the number system you're used to working with, and you've learned for many, many years now. And it works using these columns, which are all powers of 10. There are also, if you think about it, 10 possible digits. 1 through to 9, which is 9, plus 0, there's 10 possible digits. So 10 is a big number here. Each column is a power of 10, and there are 10 possible digits that can go into each column. That's base 10. Now computers, unfortunately for us, don't use base 10. It's a bit too hard for them to deal with. So they instead use base 2, which is called binary. Now if you think back to what we had before, in base 10 everything was tens. Every column was a power of 10 and there were 10 digits. So what now? We're not using base 10, we're using base 2. What happens? Oh, every column is a power of 2. So if I write my column headings out, do a few of them, I start at 0 and I count up for the powers. 0, 1, 2, 3, 4, 5. So here, these are going to be my column headings, all powers of 2. So let me stick the columns in just to make things a bit more organised, not necessarily neat, 'cause I'm not doing a great job of that. Now, that's great, we've got all these powers of 2, but we need to think about really what they are. Anything to the power of 0 is 1, so 2 to the power of 0 is 1. So the first column, just like in base 10, it's the 1s. 2 to the power of 1 is 2. So the next column isn't 10, as it was in base 10, it's 2. The next one is 2 to the 2, which is 4. What you'll notice is each time, just like in base 10, every time you times by 10 to get to the next column, in base 2, you times by 2. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2 is 32. So there's some of the columns in base 2. Just as the same way in base 10 that they keep going as far as you want, here we have, these can keep going, we just have a few of the starting ones before we get into really big numbers. So the column headings for binary are here. And we can make numbers in just the same way as we made them in base 10. In base 10 we've worked out how many hundreds there were, how many tens there were, how many units there were, or ones. In the same way we do that here. So if I do an example, let me write the number 9 in base 10. So that's how I write 9 in base 10. The base can go at the bottom. What's that in base 2? How could I represent that in base 2? Well, I would represent it. I don't want any 32s, I don't want any 16s. I'm going to have an 8. 8, how many more do I need to get to 9? I need no 4s, no 2s, and 1, 1. So what that means is, that's saying I've got 1 times 8 plus 0 4s, which is 0, 0 2s, which is 0, plus 1 times 1. That is the same as saying 8 plus 1. So the value I've represented here is the value 9. So I've written it out in denary, the working out all in, base 10, also called denary, But this is how you write it in binary. So that the number 9 is represented in binary by 1001. Isn't that confusing? So I'm going to stop there and give you in the next video some examples just to try and get your head around making up numbers using powers of 2, and then I'll come back and explain a bit more about it.